Welcome to this second hands-on session in the first year project. What we want to do today is talk a little bit about the Handins system one more time, then a short note on observer patterns, because some of you gave me a very nice message there. Most of the time we're going to work on Handson 2, line drawing. Yeah, the goal is going to be to draw something like this on the screen. Many of you will be a little bit disappointed because this will take like 5 minutes. But then we have a lot of other things that we can work on. Yeah, and let's see how far we get. And then, again, you take it from there. Yeah, we do something today, you take it from there, you hand in something next week right before the lecture if you choose to. Let's first talk about the Handin 1. So let's look at numbers. Current numbers. So there are 58 submissions through Learned. That's quite a lot, I'd say. And on GitHub, there are, I think that's pretty accurate. So we have a 7, 10, 13, is that 17 submissions on GitHub. Yeah? When did you? Okay, it takes a short while because it goes to all of these 150 repositories, checks is there a release called Handin 1. Do you see yourself now? Yeah. I mean, you can have a look whether you called it. The exact time. Yes. Yeah. If it's not that, my script is going to say nothing happened. Oh, please check that. Okay, but there is quite an imbalance. I'm very happy with the total number. The total number is around 70 of you chose to submit something. That's very nice. Now I'm going to distribute that to the TAs. They are going to give you feedback if you want to. They are going to check what you did there. What I don't like is the imbalance. Like I think last week I asked, do you feel comfortable using Git? And most of you said, sure, I feel very comfortable using Git. But then if we look at these Handins, then we see actually you're much more comfortable using Learned. Yeah, so that was far easier for you. What we chose to do is that we still, like for Handin 2, you have to use this Github system. So you should be working with that from now on. And let's just go through it one more time. So what do we want to do? Let's say we want to make a Handin. And what you should have, all of you, is a repository. So if I go to github.itu.dk and Milk created Handin 1 just now. Where's CS created Handin just now? Okay, I think now there are some more Handins there. But you see, like under your repositories, I see a lot of repositories, and that's all of you working. On your project, please make sure that you see, if you go to github.itu.dk, you should see a single one. And that is BFST18 _ your ITU handle. If you don't see it, then you didn't have a GitHub account when I created all of these repositories. So just drop me a message, write me an email saying I cannot access my repository, that's my handle. Okay, then I'll add you, and then you should be able to work with the system. Okay. Once you have it working, yeah, you go to your repository and let's just say okay, a lot of you worked on that. There is the public one. Let's just say I want to create a Handin now for Handson 2. What you have to do is you have to create a release, and there is a screencast for that, but let's just go through it one more time. You click on releases here, and then you say draft new release when you feel ready to do so. You call, so the tag that you give is Handin 2, if it's for Handin 2. You can give a release title. That is not so this is, I don't check this, I only check for this name here, the tag, but not this name. Okay. And then there's something you should write. And what you should at least write in there is what we tell you to write in the Handin description. And that is, you should add a jar file. You should add a screenshot of your program. showing the awesome graphics you have made. I think a lot of you made pretty awesome Handin 1 things. I think Handin 2 is going to allow a little bit more of awesomeness in the graphics. And then please also give a short description of how to run your program. Yeah, if there is something special. For example, for this first Handin, you could have, maybe some of you, I think, chose to implement that you can read addresses from a file, and you could have put this into this description. Okay, but in general, just a short description of how to run and request for feedback about your solution. If there's no request for feedback, there is going to be no feedback. Yeah, we still collect like your program, we're going to collect your screenshot. All of you at the very end, what you will get like before group formation is one file where it's like your username from ITU, and then we see Handin 1, that's the screenshot, Handin 2, that's the screenshot, Handin 3, that's the screenshot. We create this automatically so that all of you have one, and then others can look at your screenshots as well. Okay, let's go back. So we create a release, that's the important thing. Then describe this release. For example, you can run this program by clicking on the jar file, if there's nothing else to it. Clicking on the jar file. Something like this. And then two things that you should do is you should create a screenshot. How you create a screenshot is depends on your operating system. Like for me, like this was the very basic address viewer that we did last week. I would create a screenshot like this. And then this would be a file on my desktop over there. And you can just plug it in. Okay, that was a mistake. Like this. And then you see, you can run this program by clicking on a jar file, and that was another screenshot. But never mind. And then there's a jar file that you should also provide. And I created in the screencast where I show you how to create the Handin, I also created I talked about how to create a jar file from within IntelliJ. So please look at that. You take the jar file, you drag and drop it into this window here, and you go to publish release, and that's everything you have to do. Questions? Yes? I mean, on GitHub, this will basically be a push to your repository. Yeah. So if I mean, let's just look at it. Let's say I publish this release like that. Then here we see releases now 3. And the nice thing is that, for example, like whenever I wanted to check out your code, I can see like the actual version, like Handin 1, before Handson 2, there were some other tags. The actual version of your code by just clicking on this tag. That's very nice to just go through your code, yeah, because I can just do it in this web interface. And on the other hand, it creates, like it pushes something automatically. And just to show you, let's go to the, okay. So I think this is, no, this isn't. So this is the repository. And if I say pull now to get like the newest version, you actually see these new tags. So they were created for you already. And if you pull an update to your local repository, you see these, you actually see these new tags that were created there. And you could also work locally with these tags, but you don't have to. Like this is a system, like this whole system basically goes through GitHub. And it's only there for us to be able to check like what was the version of the source code. Okay? Yeah.
You rerun that script. I didn't know exactly. But I think.
Yeah. I'll do. Oh. I'll do. And then I'll put this, give this information to the TAs. Okay. That's about the Handin system. And you will see from our new task today, there is nothing to submit on Learn It here. There's a description, but you have to submit to GitHub. If you have questions, you should ask the TAs, or you just write me an email if there is really a problem with that. Make sure to watch the screencast, which you can find over here. Okay. That was basic message for the Handins system. Then one message to something that we use, but if you use Java 9, it's going to tell you that's not a smart idea to use it. And this is what we used. Like we had this model view controller where the model holds all the data. The view reads the model, but has to be notified that now something has changed. Yeah, and last week I told you a good way to do this is this observer pattern. And you do it by having the model extending observable, so it's and the view extending implementing an observer. Okay, and that's a very nice way to get automatically notifications when something changed in the model. Now, if you go to your project structure and by any chance you have Java 9 installed on your system already, there are a lot of problems still, so I usually use Java 8. Okay, and we update this, then we see the following, and it's striked out because it says it's deprecated. Yeah, so Oracle is telling us, well, you can use it, but you shouldn't. Yeah, there's no support for it anymore. And that's basically, I think, the reason for it. They got a lot of problems with using these observer patterns. They got a lot of bug reports against them. Like Oracle, you have to fix that. But they really didn't want to fix that. Yeah, and they said, that's going to be deprecated from, starting with Java 9. And there is a nice discussion. If you go Java 9 observer, I think it's the very first, like in their API. You see this, it's the deprecated. Yeah, so see the observable class for further information. And then you get a reason for why this was deprecated. Yeah. So first of all, this event model supported by observer and observable is quite limited. That's true. Because all what you get is like, if we look at how we used it down here, like the observer gets this call to update. And that's all it gets. It gets the object that is observed and an optional argument to that. And that's everything it gets. That's all it gets. Yeah, there's no information like what was the event that happened here. It's just something changed, deal with it. And you also see as we have been using it, we never looked at this object here. We never looked at who is it that calls us, who was changed. And this is one problem. So because whenever you want to use this object, it becomes really ugly because you have to start, well, is O is an instant of model, and then you do model M equals model. Oh. Yeah, you always, that's like how people use observer. Yeah, and that's really ugly. Yeah, because you get these long lines of if statements to check first who was it that called me, and then you just cast it statically to, that's a model now, and now I can use all the methods that a model comes from. Okay, and that's I mean, we kind of avoided this anyways by just using the model over here, but in general it yields really ugly code. Okay, then there are some, the order of notifications delivered by observable is unspecified. I think they got a lot of bug reports against that, because you would think like if I subscribe to an observer, then if the observer says something changed, it should be in the same order, but that's something that you can decide on a user basis if you want to do this or not. And then they got a lot of bugs where they assume things have to be in this order, but somebody said no, not here in this program, and I mean, that makes them write these things. And what can you do? I played around with it and I saw some of your Handins change that, and I'm also going to look at that if I like it, like the way you did it. There is this Java Beans package, and that one has a lot of notification. Like this one has like something like property changed, events, and listeners. Property change, listener. Yeah, how to write one. This can be quite nice. Like the model says one of my properties has changed and actually tells you this is the property that has changed. How I saw it being used in your Handins was also then statically casting against what you think was the data type. So there you get an object back with this is the new object, and then you have to say, it's the model, so it's probably this array list. So I'm going to statically cast it to array list, and then I'm going to work with that. Yeah, I think it doesn't really help. Here, and then there is something very nice, but this is only for Java 9. And that's this Flow API, and I think it looks really nice, but it's really not obvious how to write code like this. Yeah, so I hope you agreed last time on what is happening. We had this array list of just storing some addresses, and that was it. Yeah, and we read this. And with this Flow API, you can also build like such it's not a list, but it's a stream. It's going to be a stream of addresses that you're going to subscribe to. Yeah, and then whenever something changed, a new address came in, then you actually get the address. And you should do something with it. I think that's pretty nice, but it's Java 9 only, and it looks not beginner friendly, I would say. Yeah, if you can go to this Flow API and read through it, how you write it, but it's really not obvious. It wasn't obvious to me. So what I choose to do is that we just stick to the observer pattern. Long story short, message, I'm going to stick to the observer. Yeah, and it's not going to be removed. Yeah, so there are some features that were removed from Java, and then you get first a deprecation, and then you get a version number where it's going to be removed. But they chose to not remove this, and I think they won't remove this in Java. But it's going to be deprecated, and whenever you tell Oracle, I use the observer, I have this bug, please fix it, they will going to tell you no. I mean, you shouldn't use it, we deprecated it for that reason. Okay, that was about the observer pattern. Yeah, so this is striked out. Let's switch back to Java 8. And yeah, everything's fine again. Yeah, if you want to stick to Java 9, then you can also say, well, these deprecation messages, I don't want to see them. Okay, what else? Let's start with what we want to do today, and that is we want to work on Handin 2, and that's line drawing. So what we're going to do today is we do a lot of drawing on a canvas in Java, and it's about drawing lines. It's about how do you pan, like how do you zoom in, how do you zoom out to such a map, and yeah, how do you like go to the left, go to the right, go up and go down, for example, using the keyboard or for example using the mouse. And I hope that's going to be interesting for you. It's definitely going to be interesting for your project, because there you have to implement this routing software, and the most basic thing is you have to be able to draw a map. And today we're going to get somewhere. Next week it's going to be already much better, because then we use actual data. So what's the task? We want to write a model view control-based program that is able to read and display files of the following format. So we have one line per line in the file, and there's a very simple format associated. It says line, and then an x, y coordinate, that's the starting point, and then another x, y coordinate, that's the ending point. The task is draw the line between those 2 points. Yeah, and there are some coordinates, and I tell you all of these coordinates are in screen coordinates. We have to talk about what are screen coordinates, what are other kinds of coordinates here. I think that's going to be the difficult part of today. Let's look at an example. This is, for example, a line. This is a file containing 8 lines. Yeah, and you see the starting point is at x, y, this point, and we should draw a line to x, y, this point. In the following, when we are talking about screen coordinates, we have to look at the screen as follows. So this is our screen, and up here in the top, there's coordinate 0, 0, and down here, it's going to be, for example, I think for us 500, 500 in the beginning. Okay, but whenever topmost is 0, 0, bottommost is whatever the width and the height of our canvas is. Okay, I already created a prototype to avoid like starting to reprogram all of these things we also did last week. So let's just have a look at the prototype. And that is Handson 2 here. Okay, and what we see is we have two controllers, one for the mouse, one for the keyboard. We have a model, we have a canvas view, and we have a main window. If I run the program, it's pretty boring. It has a window called Line Visualizer. And here's another window, but this one is just empty because we never drew something. But to make it, just to look at the code here, the main window is our main window. So there we say Line Visualizer, we say that's the border layout, we say what is the exit condition. But most importantly, we get another view, our so-called canvas view, and we want to draw on this canvas view. And we add this view to our main window, and the preferred size is 500, 500, but because we use one of these layout managers, we'll also be able to just resize our window. Okay, we pack and set visible. That's the main window. The window we want to draw in, that is our canvas. Our canvas knows our model, and our canvas is the observer. So the canvas always asks, like in the model, is there something new to draw? Should I redraw, like the image now? It's a J component, and the most important method today is going to be paint. In paint, we say what we want to paint. We get a graphics object from Java, and you can also do 3D graphics, and it's like, and that's the interface graphics. So all of these programs, also when you look at the documentation, they usually start with this hard static cast to graphics 2D. Yeah, and that's the graphic object that we then want to work with. Okay, and there is something called stroke. We can get to this later. But all we want to do, that's something I added already. We want to draw all the lines that we have in our model. So we go through our model, and we just call g.draw line. And this draw can take any kind of shape it knows and draws it on the screen. Okay. And then the update method, the only thing it's going to do when we saw something new in the model, we call repaint. Yeah, and repaint is going to invoke paint and is going to redraw all of these lines. Okay. What's the model? Our model looks almost exactly like last week. But instead of a list of addresses, we have now a list of lines. And in Java 2D, a line is represented by the object line2D. Okay? And this is a new array list. And what we first have to implement is we have to read somehow from our file. Okay, but this read from file, currently it doesn't do anything. There's also an add method where we can add a single line. And there is this dirty method. This dirty method just says something has changed, and let's notify all of the observers so that all the views are going to redraw the lines that we have in our model. Okay, and we have this iterator, like last week, where we just can say that we can iterate through all of these lines in this very nice fashion. Like this. Okay, and then there are some controllers. The keyboard controller and the mouse controller, but that's something that we talk about when we need it, let's say. Okay, questions to the basic prototype? Yeah, I think, I mean, it's a bit odd to start with something that is already there. It's very, very close to what we did last week, so I hope that's okay, and you'll understand some of the features once we work with it. So let's go to our first task. I'd say our first task is to find the description of the task. And what do we want to do? We want to visualize. We want to draw these lines. And that's the small input. And they're tiny, small, medium, and large. Let's look at the format one more time. So a line starts with line, and then we have these 4 coordinates. That's something that we want to pass. Okay, so now we have a file. We have to be able to read this file. And we have to, make sense out of these little individual lines. Okay, so let's start with reading a file in Java. There are many ways there are probably two ways that you've seen, like from the Handins. It seems like many of you use a scanner to read. Like when you did address parsing with the autocomplete feature, you also had to read lines, and then there I saw that you use a scanner for reading lines. There's also something called a buffered reader. And just a show of hands, like who of you used buffered reader before? Okay, who used the scanner? Oh, it's like almost opposite groups. Did you have it in the Grundlehne Programmering file reading? No, okay, but a lot of you did it already. Okay, but there is really no magic to it. I use the buffered reader. The buffered reader, you can look like buffered reader versus scanner, and they will say, like, if you read a file, like, use a buffered reader, much faster. If you read a file looking for certain tokens, then a scanner is much easier to write. But for us, it's like each line is going to represent something. It's going to mean something. So we are going to use a buffered reader. Let's say buffered reader, let's call it B, equals new buffered reader. Okay, so that's reading something, and what do we want to read? We want to read from a file, and that's the so-called file reader. Okay, now without IntelliJ's help, you have to remember a lot of things. Like what could go wrong? I say new file reader file name. A lot of things could go wrong. For example, this file could not be there. Yeah, then we would get a file not found exception. Other things can happen, and what I'm just going to use is, let's look at what IntelliJ tells us. Like, there is some exception. We can add it to the method signature, but I actually want to surround this with try and catch. So we want to try this call to buffered reader, and we could get a file not found exception on that. Yeah, and all I do is I print the stack trace. I think that's the canonical way of handling file not found exceptions. I mean, you could also like terminate the program at that point, but we try it. If it fails, our lines array is an empty array. We get a print on the stack. We get a stack trace on the terminal, but the program is still going to run. Yeah, but nothing going to be shown. Okay, what do we do with our buffered reader? We want to go through our file line by line. The canonical way of doing this is that we say, let's start with the first line, read line. We see another problem here. I mean, if it's this call immediately, then we also see there could be a problem now with this line. Yeah, what could be the problem? Well, this could run an I/O exception. Yeah, we could, for example, you can do many things on files. Like you can have a file that is that long, and you ask, like, what is the symbol over there? And then you get an I/O exception because there is no symbol over there. Yeah, you went too far in your file. That's the I/O exception. One of these I/O exceptions here. If you were to look into read lines, what happens? Like now we want to read the file line by line. When do we stop? We actually stop when this read line returns null. Yeah, so as long as line is not equals to null, then we say line equals read line. I think this looks, or I hope this looks a bit obscure to you, but like if you don't do it like this, Java programmers are going to tell you, I've never seen it done otherwise. Like this is the canonical way of reading a file line by line. Yeah, you have this initial line. Whenever you go through one for loop, you call read line again. And this is the stopping criteria. Like the stopping criteria is if line equals null, because only if we reach the end of the file and we say read line, then it's returning null to us. Okay, let's look at these lines. They look like this. So now there are two choices, and I go for the quick and dirty way. Which maybe I shouldn't do. Yeah, but then you can take this program and go wherever you want and maybe make it a bit more robust. I'm going to say, well, this is exactly what I want to see. I want to see such lines. like this. Yeah, they are split by a single white space. They start with line, and then there should be 4 numbers that I see. So this is something that we can ask Java to do for us. We can split by regular expression, and this regular expression is going to be a single blank character. And now what we expect is that token 0 is, let's do it like this. So this line.split takes all the white spaces and splits around them. So this is going to be the first element of the array, the second element of the array, the third element of the array, fourth, fifth. Okay, that's how split works. So we can ask, is the first token line? And if that's the case, then we want to read a lot of coordinates. Yeah, we want to read this very first coordinate, and that is stored in tokens 1. But we have to make a double out of that. Yeah. And I just wanted to check that IntelliJ is very intelligent. So what do we want to do here? We want to replace this. We want to parse the string and convert it to a double. And that's actually what IntelliJ tells us as one option. So you can do this double.parseDouble. That's the way to pass a string into a double coordinate if this is possible. Okay, and so on. There are a lot of other coordinates we want to read off. There's y1, there's x2, and there is y2. Okay, and these coordinates are like this. Okay, then we should have 4 coordinates now. What we need to create is a line from that. Okay, and what we say is we have our lines, and we want to add a new line object consisting of doubles. And one of the constructors is just x1, y1, x2, y2. Yeah, there are other constructors where you give 2 points. Because this is I hope the naming makes it clear, but this is like just a list of 4 doubles. It's a bit strange, like what's the meaning of these 4 doubles? We take it like this because of how we read our file, but it would actually be nicer to say this is point 1 and this is point 2. And we are talking about points a bit later as well. We read the file line by line. We check is the first token line. If so, we pass all the other coordinates and we create a line from that. Who thinks this is going to work? Oh? Why is it? You didn't raise your hand, did you? Like, why is it not going to work? Oh, I don't care. Any one of you. Maybe the one in the bottom. No? Yeah? Yeah? Oh, wait. Yeah, what's the problem? It's right, it won't work. Yeah, this, you don't want to look at this. You don't want to look at this method. Double.parseDouble. I mean, please look at it. It's like really difficult to parse a string into a double. But it's really the way to do it. That's not the issue. There's another issue. Yeah. Yeah. Maybe that's it. Yeah, that's the problem. Okay. I hope yeah. But all of you knew it. Like I asked, does this work? I don't know if you felt like I have something in mind with this question, and it was rather why would he ask that if it's that obvious? I mean, it should obviously work. Yeah. The problem is this. Okay. No. Let's just run it like this. Okay. I mean, we do have our canvas view, which should go through all the lines and draw all the lines. So let's just look at what happens with this program here. No line. Oh, but there's something else that I forgot to do, I think. How do we read? Actually, yeah, we shouldn't use this one. How do we read our lines? That is through our main method. I say when there are some arguments on the command line, then I pass these arguments to our model, and our model, if it gets a argument, it's just going to call read from file. Yeah, and usually you would just append like this file, like the file name on the terminal, and in IntelliJ you first have to run the main method once, so that it knows this is actually something that I can invoke, and then you can say program arguments are our path to this file. And on my setup it's this, and I also put it on GitHub like this. All of them in this data directory. Okay, so nothing happened here because this was never true. Yeah, if you want to look if things are equal, like content is equal, but not their address in memory is equal. Like this equals is this the same object? And you don't know whether this string is the same string as the other string. Yeah, but they will have the same. There we go. Yeah, so that's maybe some of you. I don't know. Maybe some of you saw this here and said, "Aha." Of course. I mean, what else can you do with 8 lines? And drawing that. Okay, but this is how we draw lines. So this is file reading. We draw lines. Of course, the difficult part was to pass things into this format in the first way. Let's look at some other. Let's look at the other files that I've provided to you. There's 20K. That's 20,000 lines. Yeah, and that is. I mean, that's what you can do with 20,000 lines if you want to draw some part of Copenhagen. And then for people not from Copenhagen, I think there is something else as well. I had to first Google that. I mean, I'm not Danish. I'm pretty sure you say, No, that's also Copenhagen. That's one step up. What was the big file? So this was the third out of 4 files. And I think this was how it was called. So that's 336,000. No. No, that's not a single line because this file doesn't exist. Let me just check. How did I name this file? Lines. Lines. There we go. But here we see what happens when the file not found exception is invoked. Yeah, you get the stack trace about what has happened and where it happened. There we go. What do we see? Aarhus. Yeah, precisely. And we see there are very dense areas. This is only black. Yeah, and now we have to work with this a little bit. Okay. But so those are the files that you can visualize that I gave to you. It's of course a bit cheating because I first had to take actual data, move it into this nice lines format, and now I open lines and you say, yeah, but it's a bit cheating. Next week we're going to improve on that. Okay, now we can draw lines. I would say it looks a bit ugly, like when you look at these lines here. I don't know how good you can see it, but there is this one line you can see because of the resolution, it's not very smooth. Yeah, but these lines, they go like this. So let's, before we take a break, do one small little feature, and that is that I want to use a technique called AntiAliasing. To smooth things out a little bit. And this is something that is actually pretty tricky if you had to do it yourself. I hope you know, I hope you've like usually people that play games, they know this, like you put it on and then your game is really, really slow. And that's because it does some pretty cool work on the way. So what is anti-aliasing? To the left, we have these pixels. Yeah, you have these solid black squares here that make up this A. To make it look a bit more smoother, what you do with anti-aliasing is you take all of these coordinates and if it's a border region, like if this is black and next to it there is white, then it tries to smooth things out by not saying this is a black pixel, but this black pixel is surrounded by dark gray, light gray. You see these different shades of gray that are put on top of it. Yeah. This would be really difficult to implement if you were to do it yourself. But Java 2D can help us here. And let's just add this feature. I think to add this feature, we should make it that we can toggle it, yeah, that we can actually switch it on and off. And let's say we use our keyboard for that. Okay, how do we do this? So in our what we, compared to last week, actually added now are controllers. These controllers should react on user input and modify the state of the program based on our user input. And there is going to be a keyboard controller, which reacts on keyboard input, and a mouse controller, which reacts on mouse input. Yeah, what they get is yeah, I'll have to explain that. Like the keyboard controller gets both of the views and our model and should work with this. And let's go to the keyboard controller. What you have to do in Java to react on keyboard input is you have to implement, or you have to be a listener to certain key events. And there are two ways you can be this. You can extend a key adapter, or you can say for yourself, implements a key listener. Okay, what's the difference? One is extends, the other one implements. Now the difference is that if I implement the key listener, you see this is like underscored now with red, because I have to implement methods. I have to implement a key typed, I have to implement key released, and I also have to implement what I already had here, and that is the key pressed event. Okay. If you implement the interface, you have to provide implementations. Maybe they are empty for this. If you use so the question is, what is the key adapter? The key adapter implements the interface and provides no implementation. Like the implementation is empty. But that means you can implement something that reacts to a keyboard, but you only listen to key pressed events. Yeah, you don't have to do key released if you're never going to be if you don't care about these key released events. Okay, that's usually the way to do it. But then on the other hand, if you want to extend from something else here already, then you have to implement, because you don't have this multiple inheritance in Java. Okay, just to give you an idea, what is this? Like I can react to key pressed. I can ask this, let's just print something. Keyboard equals plus e dot. And the most useful function is get the character of the key that was just pressed. Get key character. Okay. We have to say our controller listens to these keyboard events, and you do it like this, by adding a key listener to a component, yeah, of your GUI. And you can add key listeners to all of these components. Now, I have to add the key listener to window.view. That is our mainframe. And I also added, and that's a bit odd, to our canvas. That's where we want to draw. That is because when I checked, like on a Mac, when I type something, somehow it's up here on the main window. I asked someone with a Windows PC and he typed something and it never worked. And that is because on Windows, that was the one that sent out the events. To make double sure, we just listen to all of them. Yeah, and hopefully, you tell me, like if you're on a Linux and tell me, oh, it doesn't work. I have to find out like what's the problem now. What else can we listen to? Okay, but there's key pressed. The idea is a component of our user interface fires these key pressed events to all its listeners when there is a key pressed. And this is something that you, of course, can't really see. Here, and it's also, like, let's say I press an A, then it says keyboard equals A. If I press W, it says keyboard equals W. Very, very impressive. Okay, let's add one feature to it. How you do it is you make a switch statement around these characters that you want. Let's say I press an X. What I want to do is that I want to toggle this technique called anti-aliasing. So first we have to say, well, our canvas, let's make a method, toggle anti-aliasing, like this, and then break out from that. And there should also be a default clause if we something else. Okay. And now again, like usually you would go now to the canvas and create these methods. I'm going to use IntelliJ to do this and create this method for me. Talking about toggle anti-aliasing. What I want to do is basically I want to have a Boolean flag which says, do I currently use this technique or not? Let's call this Boolean flag use anti-aliasing. And I want to toggle it, anti-aliasing. So my home method is going to do this. And then I also have this field, use anti-aliasing. Okay, yeah. I also, after it, I should repaint the screen. How do I set up anti-aliasing? You have to set it up every time you paint. You have to say, should it be used or shouldn't it be used? So we ask, should it be used? And then there are a lot of things here, what you can do on a graphics object in Java. And we are going to use font metrics and get font and all of these things later. So we'll set a paint, we will transform something in the second half of this lecture. But here it's a hint to how it should be rendered. And let's look at these hints, like rendering hints. What can you do? For example, you can use anti-aliasing. And yeah. And I hope you are not, I mean, it feels a bit weird also to me, like if you use IntelliJ, how much you rely on all these things. Yeah, that's just the world we live in, I think. Yeah, I think I would still be able to type this out myself, but it's really, really useful to have IntelliJ telling me that's probably what you want to do. Yep, let's have a look. Did I do everything correctly? We will see. So this is Aarhus. Yeah, and that's the anti-aliased version of Aarhus. Okay, hi, let's continue. One small detail on GitHub. I think you could get that wrong. It's so you do have your own repository, and but what you have to make sure, of course, like for example CAIW, what you always have to make sure is that your local version of the code is the same as the one on GitHub. So it's not automatically done. You have to do it yourself. Like let's say we now have a initial version of our line drawing. So I go to this directory. I ask for the current status, and then I modified a few files over here. So let's just add those. And let's make a commit. Okay, this is basic file reading, anti-aliasing feature. Okay, and that's the commit. That's something locally. So when you go to, So when I go to our public repository for this session, there's nothing here. It still said edit basic prototype. That's something I did 2 days ago. Yeah. So what you have to do is you of course have to push. You have to publish your own version and put it on GitHub. And that is done by git push. And when we now look on this repository, we see there was a fifth commit, basic file reading, anti-aliasing feature. Only when your version of your source code, the local version, is the very same as the one on GitHub, as what we see right here, then you go to releases and make a release. Not before that, because otherwise TAs are going to look at what I told you to, as like at basic prototypes, but not at the actual source code. So you have to do this step manually. You have to make sure that your the version on GitHub is the very same as on your local PC. Okay, cool. Let's continue. So we have this anti-aliasing feature, which is, some people, I think, agreed, impressive here. Maybe, maybe not so impressive over there. You can try it yourself when you're home. And what do we want to do? Let's just take some features here. So this works. Yeah, and we even have this nice anti-aliasing feature. Let's say you're allowed and extend the functionality of the program as follows. Let's do panning and zooming with the mouse. Adding new lines to the model, saving the state, adding other graphic primitives. Let's start with this panning and zooming, and let's not do it with the mouse, but now we talked a bit about what to do with the keyboard. Let's just stick to the keyboard and let's explain ideas over there. Okay, what do I want to do? I want to be able to go left and right to pan. Yeah, and I want to be able to do this using the keyboard. And how are we going to do this? Let's go to the controller. Now add some buttons that we want to react on. And I'm going to use W and A and S and D for this. So W, if you look on your keyboard, W goes up, S goes down, A should go to the left, D should go to the right. You might wonder, why doesn't he use these key arrows that you find on the keyboard? That's unfortunately very difficult to do in Java, yeah, because this is like the key. What is the character? And if I go to our program over here and I'm going to press upper, like this arrow up, and there we go back here, then it says the keyboard character pressed is this, well, it's not a symbol over here. So that's a bit odd. And we're not going to use these keys. If you want to use these keys, there's actually something else you have to do. There's this key listener, and there are key bindings that you can set up, and that would be the proper way here. Like all these function keys, the arrow keys, all of this would be by providing key bindings to your program. But you would have to Google that. Let's stick to W, A, S, and D. What we want to do is very simple, actually. We want to call the canvas and say, well, now if I press W, I want to go up a little bit. And this up operation is, let's call it pan. And then let's say we provide an X coordinate and we provide a Y coordinate. W, this is, that's something I didn't tell you, but yes, you know this. This here is X, and this is. Okay, so when I want to go up like this, the X coordinate shouldn't change, but the Y coordinate should change. Okay, so let's just try something out. Let's say nothing should happen here, and let's say 10 pixels. That's what I want to move. And let's see later if we have to say 10 or minus 10 to go up. Okay, the pan operation, let's create this method. Okay, and this tried to be very smart, but this is not what I want to do. Those should be doubles, especially when we want to use mouse input then. Okay, we want to pan by X and Y. Now this is actually something pretty tricky, because there are screen coordinates, and these screen coordinates are 0, 0, and if we start the program 500, 500. Yeah, so this is what we expect. So what we actually want to do is, like if our picture here, if this picture is here and we want to move it up, what we actually have to do is we have to change where the screen is. Like moving up like this would mean that actually your screen is maybe down here. Yeah. I hope you get the idea. Moving up would be setting the screen down. Yeah, then this sun here is on the in the upper area, on the top area of the sun. That's what we want to do. How do we do this? We have to apply something that was already a suggestion, and that is called a transformation. So what we're now going to do is we're going to transform where our screen is. And it tells you there's an affine transform that you can provide. Okay, let's just make one, and then let's discuss what this is. Oops. So we add this transform, and this should be a field as well. This is our affine transformation. Okay, and then let's just look up what is this affine transform. We are over here. So the affine transform is a 2D affine transform that performs a linear mapping from 2D coordinates to other 2D coordinates that provides both straightness and parallelness of lines. So the important thing is, before you have x and y coordinates, and then you provide a matrix such that the final screen coordinate is going to be x prime, this entry. So you perform an operation, a multiplication with the original x coordinate and multiplication with the original y coordinate, and you can offset that one. And the same thing is true for our y coordinate. We can set x and y and an offset. And that's the operation that we want to use. Here, the affine transform, what we actually want to do is, we have an original y coordinate, and this y coordinate should change. This y coordinate should be something else because we want to move the screen in this direction. Okay, and now you could think about, okay, now I have to set this matrix for myself. So what I want to use is the new y coordinate should be the old y coordinate over here, and then I want to change that because I want to go, for example, 10 up or 10 down. Yeah, this is the entry I have to provide. Now this could be horribly difficult because you go to look at this matrix, look at, this cell is something that I want to change, but that's not at all how you use it. How you use it is, you go to your transform, that's the original one. A new affine transform doesn't do anything. Yeah, the x and y coordinate is just not changed. But what you can do is, like, you can say, I want to use this transformation, and then I want to put another one on top. We are going to discuss this. And what kind of transformations does Java give us? Here it's a scale instance that's going to be zooming in and zooming out. There is a translate instance, rotate instance, a lot of rotate instances. Yeah, what we want to do is we want to translate. We want to have x and y, and we want to translate this. And it tells you, well, you say how you want to translate it by providing an x and a y coordinate. That's what we want to do. And oops. Let's then just repaint what we did. Let's first check out what just happened. So we have this pan operation which takes the original transformation that we had. So before we use this pan operation, again, there was some transformation. This transformation is, for example, maybe the one I showed you here. Yeah, the one which takes the screen and puts it down there. And this pre-concatenate means now take that one and put another one on top. Yeah, so it's like here, and then pre-concatenate with the one that moves everything to the left, then a little bit to the right, then the screen would be. Yes?
Could you turn on the blackboard light?
Yeah. Ta-da. Okay. It's more the usage, I think, than so I think the usage is very easy. The theory behind it is a bit difficult. Let's see. Okay, but I hope you got the idea of what should happen. Let's rerun our program. Let's press W. Oh, Here we go. Yeah, very. And nothing else works. I mean, all the other keys are not set. So let's set them as well. So we want to A, and I got very lucky here by providing the right coordinate. I think this should then be 10 as well. Let's say S coordinate, and there is, so S should be down. Oops. And down means no change to the Y coordinate, X coordinate, but now the opposite direction on the Y coordinate, that would be minus 10. And then we want to, on D, we want to go to the right, and that should be a minus 10 here. Okay, let's rerun. Yeah, I mean, it's more impressive for me to actually press the buttons, but you actually see, like, he can move in all the directions. Apparently, this feature works, and I can also draw it a bit nicer here. Okay, but the main difficulty here, and we'll get to this in much more detail in some minutes, is this translation. Like, there is this screen. It's always there, and you always have to translate where you currently want to look at. Yeah, and you do this by providing these transformation matrix. Yeah, that's a affine transformation. And yeah, maybe just to tell you, like, if you're not using this pre-concatenate, what would happen? If you were to set this, like, the new transformation is this affine transformation. I don't know if you already have an idea of what happens if I don't concatenate them together. Like, I press A, this works. I press W, I press S. I mean, I don't know if you see it. The only thing I can do is I can move a little bit in the right direction. Because it always says, like, the whole operation I want to do is move a little bit in the X direction. With this pre-concatenate, I concatenate all of the previous operations and the new one together. Yeah, and then it's actually doing this flow of operations at once. Okay. I hope you get the idea. Okay, so that's what I want to do. I want to concatenate here those transformations together. Okay, what else can we do? We want to zoom, and let's just directly start. Public void zoom, double zoom factor. And here as well, I already showed you that there is a transformation which says zoom, and that's a scale instance, and we want to scale in both directions at the same time, like this. Now I hope you agree this panning, that was simple because you just had to change X and Y. Now zooming in and zooming out is really difficult, because when you zoom in, like, you had an X and Y coordinate here, but they have to be stretched. Yeah, or like they have to be stretched out to zoom in, or they have to be stretched in, be stretched. Okay, that's something that I maybe only know in German. To allow this. Yeah, but each XY, so there has a lot has to happen here. But you can get this scale instance. Let's just zoom a little bit, and I say how do we zoom? We press on plus, and then we zoom, we zoom maybe by a factor 1.1. Like, a scale instance with 1 means no change, 1.1 means zooming in, and zooming in by, let's say, about 10%, and then there is zooming out, which is a factor that is smaller than 1. Let's say 0.9. Something like that. Let's see. Let's press plus. Okay, and the strange thing here is, I mean, I don't know if you were the user, I mean, I would be a bit surprised by what is happening, because it zooms into a really, really strange place. Yeah, do you see this? Like, where does it zoom in? It zooms into this coordinate over here. Yeah, I don't know. I think this is like, if I were to use Google Maps and I press plus, yeah, I expect that I zoom in exactly like to the middle of the screen, nothing else. Yeah, I don't want to zoom into the upper left corner. Yeah, I want to zoom into what I want. Okay, what's the problem? Apparently, the problem is that the scale instance like works around the origin over here, but we want it to work through the middle. How we are going to do this is, I mean, that's the scale instance. You can't change that. Yeah, it's always going to zoom in to what is currently up there. But we do have a nice way of moving things around already. So what I want to do is basically, that's the screen over here. Now I know when I zoom into this point. So what I want to do is I first want to pan the whole screen to be over here. Yeah, zoom in and go back. Yeah, I want to do it like this. Yeah, I want to move the place where I zoom in to be. Is this the right way around? I think it's actually the other way around. We'll see it when we pan that I might get this exactly wrong. Let's call this zoom to middle, zoom to center. Yeah, what I want to do is I want to pan. So I want to move everything so that my current middle point is 0, 0. So I ask, like, what's the current width? Half. What's the current height? Half. And half these things. And then I want to go back. Like this. So I first move everything there, and then I move it exactly the same thing back again. Let's see what happens. And it's either looking good or it's totally making no sense at all. Oops. Zoom to center. Okay. Something happening? No? There we go. Let's press plus again. Yeah, and this is like the exactly the other way around. So you zoom you try to zoom in, but it always zooms to a point that is actually not on this map. So what I just did was exactly the wrong operation. So we want to, yeah. Okay. So we want to do it like this. And we do this by trial and error. Very nice. Okay, we can zoom in and we can zoom out. There's a bit of a problem here if you were to look like super closely to where these lines are. Let's say I'm going to, so this is one of these lines. I'm going to zoom in. Now I'm going to zoom out. And I don't know if you can see that, but zooming in and zooming out is different. Like it's one step zooming in and another step zooming out doesn't give the same picture. The problem is because like what I told you maybe made sense to set this 1.1 and 0.9, but if you multiply 1.1 and 0.9, the result is not going to be 1. Yeah, you do have to provide something where the result is going to be 1. And to make absolutely sure that the result is going to be 1, we say 1.1 zooming in, 1 over 1.1 is zooming out. Okay, let's not run this again. Now we can zoom here. Let's add some mouse control to that. Yeah, because we don't want to use the mouse all the don't want to use our keyboard all the time. So how does mouse controller work? Pretty much exactly the same way as the keyboard controller, but the events are different. There's also, and this I think here is really important for the mouse, there's the mouse adapter, which provides as the key adapter empty implementations for all of these methods you don't need. Because otherwise, so here I say I want to know when is the mouse button pressed, this function over here, when is it dragged, and when is the mouse wheel moved. That's what I want to know. So when is it pressed down? Then when you press down and move around, that's dragging. So then this event should fire. Now I also want to know for zooming in and zooming out, like what's the mouse wheel doing? Let's start with the mouse wheel. Let's just get an idea of what is happening when I use this mouse wheel. So what's, you can ask, like, how does it currently rotate, our mouse wheel? And this is going to be difficult for you to now see. Just a second. Okay. Can I enlarge this somehow? No, I really can't. But what we get is, like, I press up on the mouse wheel, we get these events down there. Yeah, and you see, like I tell you, like, the more I scroll, the higher the number over there. Okay, so if I scroll really, really, oh, I want to scroll over there. It ends with these zeros and ones, that's almost no movement, and it starts with 14, 17, 19. That's a lot of movement. The other way around, if I go up, I see these numbers in the opposite direction with a minus sign. Okay? Now we have to make sense out of that. So what do we want to do? What do we want to do with this information? Well, so we know it's positive when we move, when I want to zoom in, and it's negative when I want to zoom out. Let's calculate a factor based on this. We know, like, 1.1 and 1 over 1.1 were good factors, I think, to zoom in and zoom out for a single screen, for a single key press here. So what we actually want to do is, like, what I'm more interested in is actually want to do 1.1, and the exponent should be the wheel rotation. Did I measure that? Yeah, I don't want to multiply these things. That would look really weird. I want to say, well, it's like very, if I really press the mouse wheel hard, then it's like a lot of pressing on this button. And that would be 1.1 2D. Rotation, so that's to the power of 1.1 to the power of this wheel rotation. Okay, yes?
What would happen visually if you just multiply?
Then I think, like, it would still zoom in, but the effect would be, I think it would be far too fast. Let's try when it works. Yeah. First we have to think about, we had this big problem here. Our big problem was that when we zoom in, we always zoom into this coordinate. It's actually much difficult now, because now I want to zoom in wherever the mouse points to. Okay, so let's get, what I now really want to do is I want to call zoom with our zoom factor, but I also want to say at which x and y coordinate do I want this. And this is the get x operation on the mouse, and there, on the mouse event, and there's get y as well. Okay, create method zoom in the canvas. Let's do that. Okay, and again, this is double, and this is actually not a delta, this is actually x. Okay, let's refactor this a little bit. So we have zoom, and let's say the zoom to center is just a method that calls, yeah. So there's zoom down here, and what I want to do is, I want to call our method zoom with this factor and these x and y coordinates here. And this should actually be refactored. This whole pen operation. Yeah, this should pan to x and y, and afterwards it should pan to minus x and minus y. So this would give a general zoom, and zoom to center would just say what's to the middle. Yeah, and the general zoom would say to this x and y coordinate. Let's see. if this works. Oh. Okay, we see the same problem again. Yeah, whenever I want to wrap my head around these things, it's like, yeah. The picture is like this, but I always get the coordinates exactly the opposite way. So this is actually minus and minus. Yeah, very nice. I can move into there, move out, move in again, like this. Yeah, still able to do this. Very nice. What happens if we were to use, let's say 1.1 e.get rerotation? That's our calculation here. Yeah, and I'm pretty sure. Oh, oh okay. Yeah, it's like I think it immediately gets to really high values. Like it's 1.1 times 12. That's 13.2. Yeah, and that's a big scale. I don't even know if I'm able to zoom out to see a picture again. I don't know. And I have no idea, am I now zoomed out such that there is a tiny dot in the middle that I don't see? Or am I so far zoomed in still that, that I don't see these lines next to me? Yeah. Okay, fair enough, point made. Let's use this. But there's also some logic behind it. Okay. Now we can zoom in. Let's also drag a little bit our mouse around. So what we want to do is, when we press the mouse, then we know like where are we currently, and then we want to be able to move our map around. Okay, let's do this. What do we have to do? Well, when we press the mouse, it would be useful to know what's the x and y coordinate currently. So let's just, and that's something that is do we want to make a point here? So there's an x coordinate. No. If we look at this method, there's get x, there's get y, and there's also get point. Yeah, that is the x and y coordinate already as a point. Let's store this point. Point to the, let's say, last mouse position. Maybe we need to include this point. This point to D is nothing more than an object that has get x, get y, and it's generally known to Java, yeah, to this string component. So you can also, when we now say draw here, you can just say draw this point for me. Yeah, it doesn't need to be a line, it can also be this point that you want to draw. Okay, let's go down here and say our last mouse position is whatever it currently points to. And then once we start dragging around, that's when we want the map to move around. Okay, so now we look to this, and there's a point to D, and that is current mouse position. That is the point that it has now on the screen. Okay, and what do we want to do is we want to see how far did we move when we dragged around, and that's how far we want to pan our map around. Okay, so what's the delta in the x direction? That is whatever our current mouse position is on the x direction minus what the last mouse position was there. And then there's also the same thing for y. Yeah. And so we get x, get y, like this. Okay? And that's how far we want to. Now we want to say, well, pan by these two coordinates. And then, if we were to do it like this, it would always compare the point where we started dragging around with the current position. But actually what we want to do is, like, we are at the current point, we want to know that's the difference, that's how we want to pan, but then we also want to say, and the last mouse position is now the current position. such that the increments are always the same. Yeah, if you want, you can. If you can go at home, you could try it out. What happens if I leave that part out? Okay, so we get our current mouse position. We look what changed between current and last time, and then we say, and that's how we want to change our screen. Okay, and this looks like this. You can zoom in, zoom out, and all of these things work. Okay, yeah, and that's how you get basic interaction with keyboard, and that's how you get basic interaction with mouse. Questions? Let's just, yeah. I mean, it's like, let's see something. I mean, when I move around, I should have showed you this earlier. I mean, this is really, really far behind. This is really laggy. I zoom in, I zoom out. Yeah, it really has to fight here. It is running pretty slow, I agree. Yeah, the problem is, and that's something that you at some point need to include in your own project, is, I mean, you should think about what is happening. I zoom in. At this point in time, I do have something that I want to draw. Those things here. Now let's look at the actually drawing code. Where is it? Canvas view. Yeah. Our canvas view doesn't care at all about what we're currently looking at. Yeah, it draws everything outside all the time as well at the current moment. And that makes it, but the anti-aliasing is what makes it really, really slow. If I switch it off, then it feels much better. It's still a bit slow, but it feels much better. Of course, you see something has to be done. I mean, when I'm at this zoom level, I'm not really interested in like every single street. I can't even see what's going on here because there's so much information that I now need to draw. Yeah, at some point, and that's something that you will do as well in your project, you will start to you will start to say, well, that's my zoom level. Maybe I shouldn't draw everything right now. Yeah, first I should only draw what I'm currently seeing, and then I should maybe only draw what is also important here at this point in time. Maybe at this point in time, I'm not interested really in every street. That should be some of the main streets that are visible, and nothing more. Yeah, and only if you zoom in, you would say now other features become more and more important here. Okay, yeah, but it is really, really slow. Yeah. Yeah, but it's also this anti-aliasing makes it really, really slow. But I mean, there's a lot of things that needs to do. Like you take this line and you have to add a lot of shades everywhere. There's a lot of more printing going on. Yes.
What happens if you resize?
I hope. Ta-da! Yeah, that's the magic of our border layout. Yeah. I mean, it says that's the new width. That's going to, and this is going to work automatically. And there's this. I mean, there's always this model below it. Okay. One feature that I want you to show, because I think it's really important. Yeah, I think it would be a good point to stop. But one thing that I want you to show, that's why it is one of the tests, and I think you would have a hard time with that. There is this adding new lines to the model. I think that is more of an educational thing than something useful for you. But let's see what I mean by that. So what I want to do is I want to add some lines, and for this is maybe good if I only use these things, like this very small house. Okay, what I want to do is I want to add some lines. First, I kind of need to say maybe I'm in drawing mode or not. Let's say when I press L, I want to switch between drawing mode and non-drawing mode. canvas.toggle drawing mode. And if the canvas is in the drawing mode, then I want to be able to add lines. Okay, I should break here. Okay, toggle drawing mode, and that's like drawing mode, let's say enabled equals not drawing mode, enabled. That's a field that I want to use. Okay, and what I want to do is, I think the user needs some information. Now you should be able to draw lines. So let's say if we are in this drawing mode, if drawing mode is enabled, then we print some text. And let's say we want to print text down here. Yeah. Bottom right corner. That's a bit difficult because we need to know like how long is the string. And then we need to know how much space will it need, because we need to know that's the x-coordinate where you should draw. So what I want to do is I want to call draw string, and you see that was too fast. You didn't see. Draw string gets a string, an x and a y. Okay. Let's say the string is drawing mode enabled. String message. This drawing mode enabled, so what I now want to print is this message, but I don't know where. Yeah? And that's where other things come in very handy, and those are these font metrics. Like if you do something with the current font, you can ask like how wide would it be. So you can say get font metrics dot what's the string, what's the width of the string. Yeah, very useful to have this information, and that's our width. And we could also get what's the height. Get font metrics dot get height. Okay, and now I can, for example, say, I want to know how wide is it. Then I want to subtract our width and maybe some padding to the right, so another 20 pixels go off. And down there it's the height and the height of our string, and maybe 10 pixels. Oh, did I actually? Yeah, I'm pressing L, but it doesn't feel like it should do something. Because it didn't know that it should repaint. Okay, let's see. Oh, hope you see it down there. Drawing mode enabled, put in the bottom right corner. Okay, now let's add some lines. And if we look at what did we do for dragging the mouse, this is almost the same. So we go to our canvas, and we should know if it's actually in drawing mode. Return drawing mode enabled. That's a bit non-model view controller, because the view actually now knows some state. Okay. But let's say down here, so we have this mouse pressed. Now there could be two things. We want to drag stuff around, or we want to draw something. So we could ask, are you currently in drawing mode? If we are in drawing mode, what we want to do is we want to click and then draw the line. And then if we release, the line should be there. That's what we want to do. And so the easiest way to do this is we just say model.add new line 2D, last mouse position, last mouse position. That's a very boring line. It goes from first point, last mouse position, to last point, last mouse position. I would call this a point, but of course it's like a very, very short line as well. Okay, then we add this. And let's not run this right now. If we are up here, then we don't want to pan, but we rather want to, so if we are in drawing mode, we want to do stuff. And only if we're not in drawing mode, we actually want to pan. What do we want to do when we are in drawing mode? What we want to know is, what we now know is where should the endpoint be. But what we don't know is where's the starting point. So our model knows it knows this point here. Yeah. So what we are also adding to the model is something that we are going to call line 2D. Remove last. Yes. So now we add points to we add lines to the model, and we want to get these lines back to adjust where we currently are. I think it's a bit tricky to understand, and I know it's very late now, but I hope you see the effect. And when you see the effect, you see, okay, that's what was going on. So what I want to do is I want to get this last line that I created. We have all these lines. We can just ask remove the very last one. So we say lines.remove, and the very last one is at index lines.size -1. We have to say model, something changed, and we say that's the line. Okay, if we switch again to the mouse controller, we now know that here we can ask, for example, what we can do is we can look for the origin. Where did we start with our operation? And that is, we ask our model to remove the last one. And that's a line, and the line has a first point and a second point, so we can get the first point. Okay, and what we now can do is, we know where we currently are, that's the current mouse position, and we know where the origin is. So we can say new line from the origin to our current mouse position. And let's see, I'm pretty sure it doesn't work. But drawing mode enabled, I press, and I can do something. Yeah, I can draw lines however I want. You might see an issue here. Like these lines, they are somehow not where, I mean, it's a bit odd, I'd say. Where am I? Yeah, there is, I don't know where these lines go. It's really, it's really difficult. The fix is very easy, but does one of you see, why are these lines totally off? We ask for the mouse position, and then we add a line, and these lines go somewhere.
It looks like they start at where the canvas was before you started transforming.
Yeah, precisely. I should have avoided the zoom feature for this part, because actually in the very beginning, but it's a bit difficult with these stupid macOS touchpads to not zoom in at the same time. At the very beginning it works. At the very beginning it works. It's exactly at the right position. Yeah. Yeah. What? But then if I zoom in, they are still where, I mean, it's like we zoomed in, but the model just doesn't know. There is no, it's like the model thinks this is a screen that starts at 0, 0, 500, 500. That's also what the mouse is going to say. I'm currently down here, up there. Yeah, but those are not the points where I'm currently are. So last thing for today, how to fix that is, let's say there's also a method called public. Just to make this clear to you, mouse moved. I think that's the mouse event E. So just to tell you that, where the current screen coordinates are. So this is getX plus getY. Okay, just to tell you what the problem is, to show you what the problem is. So if I'm now moving around, oops. If I'm moving around here, you see down there what the mouse position is. It's at 0, 0 down here, and it's about 500, 500 down here. Yeah. If I zoom in, nothing changes. This is 0, 0. This is 500, 500. About that. Yeah, and that's the problem. We add lines in this 0, 0 to 500, 500 screen. We don't actually say this is how it currently looks. We can't take into account this is how we currently, that's where we zoomed in, or this is where we currently translated the screen. So what we have to do is we have to somehow translate a screen coordinate to what we actually see here on the screen, where this model is supposed to work like, to be, and what we do. And this is, I don't want to go into distraction of the remote. And how do we do that? Well, we ask the transformation, please transform the screen point to how it currently looks on the screen. So public, we want to put in a point and we want to get a point back. To model coordinates. Let's call it like this, and we want to be able to put a point in there. Yeah, and all we need to do is we need to say p dot transform dot, and it already tells you what you don't want to do now is from screen to these models, but you want to know what is the actual coordinate of this 0, 0 currently for this transformation, and that is the inverse transform. That's what we want to apply. Okay, yeah. So the normal transform would say so inverse transformation works like this. You get 2 parameters, which is a bit odd because there's a source parameter p, and here you can say, and this is the destination parameter, so you can put another point in there, but we just return this point. You see, IntelliJ is going to complain a lot because it could be that we give it a coordinate which is actually not invertible. There are some coordinate systems, like we say do this transformation for us, but it's actually not going to work. And then you would get a non-invertible transform exception. But now we have these model coordinates that we can work with. And hopefully all we have to do is we ask the view, the canvas, what are the model coordinates of our last mouse position? And what are the last, and over here as well. This should then be like what we actually see on the screen, and we have to do it one more time, and that is up there for the current mouse position. We have to get those coordinates as well. Okay, and this complains. Oh, I don't see. Let's see. So that canvas to model coordinates. Okay, and let's try to run that. Missing return statement. Yeah. If we really get into this problem here of this transfer that this doesn't work, then we return null. But then we are out of luck anyways. Okay, let's just see where this works. Okay, and let's enable drawing mode. This seems okay. Yeah, let's zoom in a little bit. This seems okay. Yeah, and now this is the whole thing that was missing. That at some point you need to ask, like, what I'm currently looking at, like what the mouse sees on the screen. What are the actual coordinates in our model here? Yeah, and that's why you need this transformation over there. Yeah, I know I should have done this a bit earlier, but I think this is like really important for you to see and understand that there are two things. That there is this screen here, and then you apply this transformation, and you are somewhere else. And sometimes you have to transform between